All right, everyone. Hi. How's everyone doing? I hope everybody is coming with the same smiles that they had like 2 years ago. Can I see smiles everywhere? Smiling faces? I see some distracted audience back at the back, but can I see smiles everywhere, please? Thank you so much. I am gonna share my screen now. Wow, okay, it seems like my job section is shared right now, and that's my mistake, right? I was actually exploring through some jobs, and turns out here's mostly all the X framework jobs that maybe is not my forte because I've not worked with X framework for more than 2 years now. But I really like this one particular job here. Maybe I should check with the recruiter if, that might be a good idea and that fits for me. I'm waiting for the recruiter around me. Okay, I think my recruiter has just entered the stage.
Hey Nishu, would you like to work with our front-end architecture?
Wow, my recruiter is asking me that I can still work on their front-end architecture. I've actually not worked on X framework for a while now. I'm not sure if I would be the right fit.
So I think that won't be any problem because our front-end architecture, it is more into micro front-end services. So it is more like a microservices but for a front-end. So you just have to work on the application whatever you want to and you can add it over there in our stack.
Wow, does that mean I don't need any knowledge of X framework but I can still work on your product?
Yeah, actually. Of course, you can build application with Angular, React, or whatever front-end framework you are comfortable with, and then you are good to go. You can add your application over there in our architecture, in our stack.
Wow, that sounds really exciting. I mean, I don't need any knowledge of React, for example, to be working on an Angular code base or a React code base, right? Thank you, Ms. Recruiter.
Thank you so much.
I'm going to share my actual slides now. Right. Now that I have to get into a job that involves micro frontends, I probably should learn something about it, right? You also probably would want to learn something about micro frontends. Let's do some practice and see what this is actually about. So, first of all, the best thing that I always like to do is to understand something, let's break the words and then understand it, right? The word says micro frontends, and this basically means some frontends which are like small applications that comprise towards a bigger application. Let's assume you have one big application, monolithic application that you're working on, and you don't really like the idea of this one huge application when you're just interacting with one part of the application. Doesn't really make much sense. You would really want that if you're working on the navigation project of the whole product that you're building, maybe what you're exposed to as somebody who's not interested in the, the wholeness of the project, you would want that you're only exposed to the navigation project, and that's it, right? So basically a small code base that represents the navigation project of that whole product is what you want. So maybe that could be a small micro front end, right? Let's look at the history of how applications have been, and I think we'll be able to understand the idea overall. So in the very basic example, how applications are is there would be a UI to an application, which is the front end. There would be a backend, which is delivering the data to your front end, right? So there's a backend application, there's a front end application, and that kind of comprises with a bridge, of course, which is the API that's getting you the data. That is the complete application that you have, right? The other example is where you would want that there's separation of concerns. You would want that, for example, for any backend related operations, you have one CRUD service which deals with all the CRUD operations, writing to the database, reading from the database. Any such thing should be in one particular code base and it should not do any other backend operations. For example, there's one service whose idea is to create alerts on your Slack messenger, right? The service only does the job of creating alerts, maybe on a production error. You have a production error, you want the service to only generate those errors or alerts in your Slack channels, for example, and there should not be any database communication there. So there's separation of concerns here, right? There's one service which is doing its job of dealing with CRUD. There's other service which is doing its job of dealing with alerts, right, in a Slack messenger. So this is kind of what I'm meaning here. There's still a front-end layer, which is the UI. As a UI developer, front-end developer, you have no idea about there's separate things. You don't know about that. But what you know is that there's one service, which is the CRUD service, that's getting you the data for the front end application. Then there's other service which is doing something that, again, you basically care about one service that's getting you the data. So this is the microservices concept, where you have different services doing their own job on the back end, but on the front end, there's this one big UI that you see that does the job of showing you the interface, right? Now we think that if there's separation of concerns on the back end, why should it not be on the front end? I mean, I would want that if I'm dealing with, for example, we took the example of CRUD service, right? So we have the UI, and I want that this, this process of showing items on the UI from that CRUD service should be one project within itself. We don't want that there should be any other stuff related to any other service in one project of the front end. So the idea is all the front end applications, small front end applications which contribute towards this one front end application are the different micro front ends. What I mean here is something like this. So now there's one complete project which has its own microservices data that's coming from one service. It has its own UI, which is the micro front end. So the idea is one project for one particular task. That is, for example, let's take the navigation example again, right? So we have the navigation UI showing on the interface, and the data for it is coming from this one service, which together forms this micro front end, which has the complete idea of dealing with separate code bases. Now, we have a little bit understanding of what micro front ends are. We still don't understand clearly what micro front ends are, but with this little understanding, let's first see why would somebody need a micro front end. This feels like we are complicating a lot of stuff where there was a simple monolithic application that you could deal with, right? So let's understand from this example first of all. You see that this is a real example that we have here. You see that on the left, there's a navigation, which is a micro front end within itself. Only the navigation part, which gets its data from its own service. This is one micro front end. Then you have the top bar, which doesn't really need to interact with any other parts of your application. The only task of the top bar is showing the required icons and whatever is needed as a global thing, right? Then you have this one project in between, which is about showing the header of the project that you're on. For example, you're dealing with entities. For example, you have to show, for example, on the NG India website, right, you have the speakers section. Now you know that the speakers section doesn't really need any information from maybe the FAQ section, right? That is very different from what the speakers section has to list. So that is what your other MFE is. And then the third MFE, which seems like a drawer on the right, that is another micro front end, and the idea is to just show a list of items which were maybe done in the past, which is maybe a version history or things like that. So this is maybe where you would want to apply micro front ends, because the idea is without any communication, without any shared instances, you want different small code bases, and you don't want the teams to have to talk to each other to be building their part of the application. Now, as I was saying, we know a little bit now what micro frontends are, but you might ask me, and you might be apprehensive about this whole idea in itself. You would ask me, why do I need to complicate my application? I do not want to have multiple code bases with their own GitHub repositories, with their own pipelines. I want a simple application that does the job, has a UI, has the backend interaction, gets me the data, and that's it. Why to complicate stuff? So let's look at some points to maybe justify that. So one thing that we've already been talking about is that you would have simple, small code bases which have their own purpose. Now you know that there's one code base which does not have multiple jobs. Its only job is to show navigation. Its only job is to maybe represent the data that's coming from the backend. So there's definite purpose about each micro front end. You would avoid adding extra dependencies, for example, when you know that the purpose of this particular code base is only to show this particular UI, nothing else apart from that, right? And you would have to be really particular about all the dependencies that you choose for that application, all the maybe the ideas. Sorry about that. All the ideas that add performance issues, for example, right? So you would be really particular and vocal about such things. The second idea of choosing micro frontends is this one excites me a lot. This is about independent deployment. Now you have different repositories for each, each MFE that you're building, right? So each micro frontend has its own GitHub repository, its own pipeline. So for example, you have some changes in the navigation, in the sidebar of your application, and you don't want that there, the whole code base should recompile and you should release the whole new version of your application. You only want that there's simple change in the navigation and that's released and that's updated with, if there was stuff cached from the other part of your application, that's still cached. It's not coming from a new release version of your whole application, right? So this is independent deployment only for this particular part, which is the navigation of your application. Then there's incremental updates. Now, micro frontends mostly come into picture when you have an existing application and you're trying to migrate to a new framework, right? For example, from AngularJS to Angular. And now, in such cases, the idea is to instead of migrating the whole application from AngularJS to Angular, which seems like a complicated and a big task, you would want that maybe for this new feature, I will build this in Angular instead of AngularJS. And that should work with the rest of my application, which is still in AngularJS, but it's fine. I'm slowly building the new features in the newer version of Angular, and that's okay, right? So that's kind of the scenarios where you would want micro frontends, and that's where incremental upgrades come into picture. That's one of the advantages of micro frontends. The best part is you have autonomous teams, right? So when you're working in large projects, you know that there's, for example, 5 teams of 10 engineers each. You wouldn't want them, you wouldn't want those teams to interact on a daily basis. Like they should not have to communicate to each other a lot about the data that's coming in, right? You would want that you do your own task of building that particular feature that you're focused on without much interaction with the other parts of your application. So it should be that, separate in its own context. Each idea should be in its own. Now let's talk about integration. When we know that we are going to integrate multiple micro frontends into this one big application, because the browser is going to understand it as this one UI, right? It could be multiple bundles. It could be single bundle. But the idea is that the browser understands it as one. So we need to integrate those multiple micro frontends into this one micro frontend, which is a big basic application. So there's multiple ways to do that. One is you could integrate it on build time. Other is you could do it on runtime. Let's look at the example of build time integration. So when we're talking about multiple bundles of each MFEs, right? This is what build time integration looks like. The idea here is to have multiple MFE bundles, but they're packaged as libraries. These libraries could be published on NPM, and you could use those as library resources in your application. But you see the problem here. You're still creating this one big bundle out of all these libraries, right? There's one JavaScript bundle. That means there's still build time coupling involved, right? Because at the build time, if there's any change, you're still recompiling all of this. You're still releasing the whole project, right? It's not like one change in one of the libraries and that gets it done. That's not true, right? So maybe we're not interested in something like a build time compilation or a build time integration, but something more like runtime integration, right? And now there's multiple ways you could also integrate it runtime. The first one is iframes. I can already see some mad faces thinking, why would she talk about iframes? Nobody is interested in iframes. But that's not true. You could still use iframes with their own cons, obviously a lot of problems that there are, but you could use the bundles of different MFEs in their own iframes. Now, can somebody guess the problem that we would face when we're dealing with iframes? Did somebody say routing? We might have routing issues, right? From one iframe served as an MFE to the other iframe, which is another MFE. How do you route? Is it simple? Isn't it complicated? The next idea is JavaScript bundles, which seems a lot more simpler. You would have a script tag, and let's actually look at the examples as well, right? So for example, the iframe way of doing things. This is how it would look. I'm not sure how visible this is, but I'll kind of go through it to explain it to you. So there's this one iframe which is being used as the container with the other routes. So this is based on the route. So for example, there's one route rendered, and you decide that this particular bundle or this particular view is gonna be rendered on this particular call of the route, right? And the iframe is attached to that particular route in that case. Again, routing comes into picture, right? How will you route between different MFEs in this case? The second way is to deal by bundles, as we saw, by JavaScript bundles. In this case, you would still have a container application, but all the different bundles of, for example, the speakers page on NG India website, the agenda page on NG India website, the FAQ page on NG India website, right? The three of those different pages, you want to interact between them, but from different MFEs, right? You don't want them to interact with each other instead, apart from the routing that's involved. So here you would have different bundles. If you can see, there's a speaker bundle, there's a schedule bundle, which is actually the agenda page. And that's when we render based on the route, the right bundle. The third way of doing this is the web component way. How many of you here have worked with web components? Okay, not less people, right? So the third way is dealing with web components. It's going to be almost similar. You still have the bundles of those web components, but the only way is, the benefit is the browser's capabilities, right? When you're dealing with web components, the browser has its own APIs that are offered for web components. I am hoping you're still able to hear me with that background noise. Okay. So now that we have discussed the integration of these applications, let's talk about navigation issues, right? You might be wondering that there's an MFE that's built in Angular, there's another MFE that's built in React. How do you navigate? How does the browser know that this was the route that was last visited? How does the browser know that this is the new route that should go into the history of the browser? That seems quite complicated, right? So there are topics like soft navigation and hard navigation, and let's try to understand that with an example here. So if that is clear enough on the screens, let's talk about the first MFE, MFE1, that has the speakers route and the agenda route, right? When you go from the speakers view to the agenda view, it's a very soft navigation because it is within the same micro front end, right? You don't have any issues. The browser knows that this is the router for this MFE. One thing to note here is that each MFE in this case has their own router, right? It could be any framework, but they have their own router. So the navigation from speakers view to the agenda view was soft enough, right? There was no problem. You don't need a page refresh. But if you have to go from the agenda view to the tickets view, what happens then? It's different MFEs, different routers, different frameworks. Could be the same framework, React, Angular, but then different routers, right? How do you deal in such cases? So to avoid that page refresh from, for example, the navigation view to the top bar view or any other view, you don't want that page refresh, and to avoid that, you want the router to be on the top level instead of one router each MFE, right? So that top level router is what is important. One way of doing that, for example, you're using the React framework, is letting the history property know that the property that the routes are coming from the history instead of using the served props. So this is one way of letting the browser know that the route should be served from the history and not from this one particular router of this one particular MFE. The other way is to use some framework that applies that top level router, which could be an example I'm giving of a framework is single SPA. How many of you have worked with single SPA if you worked with micro frontends? Okay, not many people. So yeah, single SPA, as it says, is a JavaScript router for micro front-end services, microservices. And the idea is, the benefit of using these is you can choose any framework that single SPA supports, and you would have a soft navigation without a page refresh, because now you have a top level router. You don't have routers for each MFE. Even if you do, it's handled by the top router, right? The other way is you could lazy load the applications, right? You decide when your application is loaded. Maybe the drawer view, for example, is not on the view head. It only comes in when you click on a button. That triggers the drawer, and that's when it appears, right? And this is how it will look, right? If you worked with single SPA, I'm sure you already know. This is the top level router that allows all the MFEs to navigate to each other without any page refreshes. Now let's talk about the ecosystem of single SPA, the different frameworks that it supports. I'm not sure how much of this is visible, but there are multiple frameworks which are supported. You could use React, you could use Angular. In this one particular ecosystem of micro frontend, you have Svelte framework and many other frameworks, right? So all of those frameworks, and you could navigate from one to another within this top level router. Now let's talk about the different applications that single SPA supports. One application that you could create with single SPA is the root config, which is the container application, right? That's where you define all the different micro frontends which are going to be on the UI, which are going to be on the UI now or later, right? That's the container application. You have some important information like, some standard config related stuff you could have in that container application. And then the next application is single SPA applications, which are route based, right? In this case, it means, for example, the top bar, right, which has one route of its own, or maybe not that. An entity view, for example, right? You're going to the speakers page, which is /speakers, right? That's one of the single SPA applications that is based on a route. When you go to the speakers route, that's when the speakers page is rendered. When you go to the agenda route, that's when the schedules page is loaded, right? Then there are parcels, which come into picture when you don't really have routes which show up when you are dealing with multiple frameworks, or you want to render an application irrespective of the route. And the last one is utility modules. This comes into picture because you have multiple frameworks now, right? You have multiple MFEs now, and you want to share data. You want a utility application that will give you the data required for all the different MFEs. It could be, for example, a standard Webpack config that all your MFEs need, and that would be the shared logic module, which is the utility module. Now, single SPA also offers a GitHub, a CLI to deal with all of these applications. And let's quickly see how that works. Right, I'm gonna zoom this. So let's use npx because I don't want to install the create single SPA plugin right now. Now you have multiple ways of dealing with it. Either you could just pass in the module type. Here the module type is what we just saw. It could be a root config, it could be a parcel application, it could be a utility shared logic component application, right? So for now I don't want to pass it any flags, and I want to see the options which are available to me. So I would just say npx and create single SPA. Let's see what happens here. So the first thing that it asks me is what is the directory that you're looking for. Let's just call it ng India demo. That's the directory where my project is going to be. Now this is very important. This is the module type that we were talking about. You could either create a parcel application, or you could create a utility module where you have all the data that you want to give to your multiple micro frontends. Or you could have a single SPA root config, which is your container application, which is all the information about other MFEs is contained, right? So for now, to start with, I want to create a root application, right? Because that's what my MFE is going to start with. Now it asks you the package manager. You could choose whatever is comfortable for you. We want to use TypeScript, yes. Do you want to use the layout engine of single SPA, which means it has its own config, right? It has the Webpack config defined in there. It has multiple other routes created. There's a micro frontend layout file that already defines the welcome route for you. So yes, we want to follow the single SPA layout engine. Let's say yes, and any organization name. Let's just say enter. Okay, it cannot be empty, so let's call it ng. And it starts creating the application. If it creates in the time that we have, we will look at the, the created application. The second thing that we want to do in the meantime is, first of all, zoom this. We want to repeat the same process, but for another kind of application, right? Create single SPA. And now you want it to be, let's call it ng. And now you want it to be a parcel application, right? And now, do you see the options here? These are the different frameworks that are available for you to create that parcel application. You could use React code base, you could use Angular, Svelte, or any other framework that you want to deal with, and that will be the basis of your MFE. But this is only for one MFE, that you must remember. When you want to create another MFE, for example, there's one developer in your team who's not very proficient with React, but Angular, right? They would do it with Angular. There's other engineer in the team who thinks maybe he wants to explore something new and maybe try this other framework that's come in, which is Svelte, right? And you would have these multiple frameworks which do involve complications, because you would have multiple frameworks to deal with, but it's in your hand because you have defined the whole engine yourself, right? So let's maybe choose Angular, and you would see that when we give it the project name, you would see that it starts installing all the dependencies. It asks you, would you like to add Angular routing? And this is kind of similar to how the Angular CLI does it, right? They would ask you, do you want to add Angular routing to the new application you're creating? Do you want to use which style sheet format? So it's the same as how Angular CLI does it, right? And it varies on the basis of the framework that you chose. I chose Angular, and that's why I'm getting questions related to the Angular style sheet, Angular routing, etc. Right? So let's just choose SCSS. And you see how this is the same as how Angular CLI creates an Angular application, right? We see that our root config is already created. If I quickly open this and open the ng India demo directory, yeah, so let's look at the architecture here, right? A quick thing to do. So you see how it's already defined for you the micro front-end layout HTML. Let me close the side view. And there's a top-level single SPA router, which has multiple other routes inside it, which you want to define. It could be your navigation view. It could be your multiple speakers or schedules, the same views that we have talked about. It could be all of those MFEs in here. And then there's this, the welcome route that they've created for us in the single SPA layout engine. And multiple other files which you will be a lot more interested in when you're actually doing this stuff. There's this EJS file where all the import map related information is available. I will talk about what import maps are. So let's actually drift away from this code and go back to our slides. Yeah. Now let's talk about how micro frontends did complicate some stuff, right? And everything that helps us improve our productivity is always, contains some negative sides to it as well. So there's no free lunch at all, ever, right? So let's see why you would not want to go with micro frontends at all. And this is an important topic to discuss because half of the people in the audience might not need micro frontends. Why? Like my first statement, right? You would not really want to complicate your simple code base for something as simple as simple application, let's say a to-do application, right? So let's see why you would not want to use micro frontends. There's payload size involved, right? So when you're dealing with multiple bundles, there's a lot of things that you are giving to the, the browser, right? So when it comes to payload sizes, you know that there are all the MFEs which, for example, are going to use Angular as a dependency, and each micro frontend will have that dependency, or each micro frontend will have the React dependency. What you want to do in this case to ensure that React is not used as a dependency in all those MFEs, you would define it as an external in the webpack config, and that's why owning your webpack config is kind of important here, because you want to ensure that the dependencies are only loaded when you want them. You don't want each bundle to have its own React dependency in itself. So now this is defined as an external, which means that this will only be loaded in the container application as an external application, and that comes from wherever you have hosted it, right? It could be on some shared server, and that's where your React min.js file is, and that's where it's used for all the MFEs, not from each MFE. This is about the payload size, but now you see, we have kind of tried to solve the problem of payload size, but this still comes back to the build time problem. We still have build time coupling. We are still having to think about, dealing with something that is at build time, but helps us in the process. So there's always this tension going around this particular idea of payload sizes. Then the next thing is environment differences. When you're working on your local, on the micro front ends, you want to ensure that you have the right bundle access. You're pointing to the right bundle, whether it's the local bundle that you're using or the one that's already on prod, which is already maybe published. So for that we have things like import map overrides, right? And this is the package that you can use for that. This would help you point to the right bundle. It could be the local bundle that you're developing right now, or it could be the one that's on the production right now. And then the third thing, which is about the governance across multiple MFEs, which is the third point here. Now you know that there are multiple repositories, multiple deployment engines, multiple pipelines. You have to ensure that each is working fine, and that there's obviously complicated stuff involved. You have to deal with each pipeline. You have to ensure that none of the pipeline fails. You have to ensure that one MFE is not failing, which might lead to the breaking of other MFE, right? So such things do come into picture, and they're kind of unavoidable, right? But we have to take the bad sides if you want to improve the performance of our application, improve the way of working with huge code bases, for example. So, yep, that's, I think, pretty much it about the micro frontend talk, and you can connect with me on Twitter or GitHub at these usernames. Thank you, everyone.